Hello, dear students. Let us continue our discussion on refrigeration air conditioning. Last class we discussed the unit of refrigeration, that is TR. 1 TR we derived the value as 3.5 kilojoules per second. Now let us do a small problem on that. So let us read the question. A domestic refrigerator has a capacity of 200 TR when operating between -6 degrees Celsius and 25 degrees Celsius. Find the power required to drive the unit, assuming that the cycle operates on reversed Carnot cycle. How much quantity of ice can be produced in one day from water at 25 degrees Celsius? Take Cp of water as 4.187 kilojoules per kilogram Kelvin. Okay, so here it is the question given. So all of you, please take care of the units. That is the temperature units. It is given given here as degree Celsius. The Cp value is given kilojoules per kilogram Kelvin. I request all of you to always put units whenever there is necessary, so that you 50% of your work is over then and there itself. The units will always help you to solve your problems very easily. Okay, so again let us read the question once more. A domestic refrigerator has a capacity of 200 TR. Okay, so TR means what was TR? TR means tons of refrigeration, or the effect of refrigeration, or the refrigeration effect itself. Okay, and so whenever you are seeing this term 200 TR, it means the cooling effect or the refrigeration effect produced by that refrigerator. Okay, last class we discussed that 1 TR is nothing but 3.5 kilojoules per second. So here, right away, we can find out the refrigeration effect will be equal to, the refrigeration effect means the amount of coolness or the extent of refrigeration produced by this domestic refrigerator in our question will be equal to 200 TR. But 1 TR is 3.5 kilojoules per second. So 200 TR means 200 times 3.5. So it will be around 700 kilojoules per second. Okay, so reading the first line itself, we were able to calculate the refrigeration effect produced by our domestic refrigerator, which is nothing but 700 kilojoules per second. What is the meaning of this 700 kilojoules per second? It means per second, or in 1 second, this domestic refrigerator will be producing a coolness, or it will be producing a refrigeration effect of 700 kilojoules. Okay, so അതാണ് നമ്മളൊരു എഞ്ചിനീയറിംഗ് സ്റ്റുഡൻ്റ് എന്ന നിലയ്ക്ക് നമ്മൾ അപ്രിഷ്യേറ്റ് ചെയ്യണം എല്ലാ റിസൾട്ട്സും. So in 1 second, the amount of refrigeration produced, or the heat absorbing capability of this refrigeration is 700 kilojoules per second. Then we are again reading on, when operating between -6 degrees Celsius and 25 degrees Celsius. We are continuing reading the question. When this refrigerator is operating between -6 degrees Celsius and 25 degrees Celsius. Okay, so here we know it is given two temperature limits are given. One is a lower temperature and one is a higher temperature, that we have already discussed. Okay, so for calculation sake, we are taking it as T1, or -6 degrees Celsius, T2 as 25 degrees Celsius. So last class we discussed how to represent a Carnot refrigerator on a TS diagram, temperature versus entropy diagram. So the cyclic representation of a Carnot refrigeration cycle is 4, 4, 1, 2, 3, 4. So yeah, during 4 to 1, the heat is getting absorbed from the freezer compartment. So 4 to 1 is our refrigeration process. 1 to 2 is our reversible adiabatic or isentropic compression process. 2 to 3 is our reversible isothermal heat rejection process. 3 to 4 is our isentropic expansion process. So our temperature limits are T1 or T4, that is the lower temperature. For calculation sake, we are taking it as T1. So here T4 or T1 will be minus 6 degrees Celsius. Then T2, the higher temperatures, T2 and T3 are same. So T2, so for calculation sake, we are taking the same as T2 is equal to 25 degrees Celsius. So so here we are given T1 and T2. അപ്പോൾ ഈ രണ്ട് ടെമ്പറേച്ചേഴ്സ് ഉപയോഗിച്ച് നമുക്ക് എന്ത് കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റും? So we have already calculated, or we already have studied how we can calculate the COP, or coefficient of performance. COP of a reverse Carnot refrigerator, it is very easy to find out when the two operating temperature limits are given. So COP is nothing but T1 by T2 minus T1, T1 by T2 minus T1. So T1 and T2 are already known here. It is straight away given in the question here. So we can easily substitute in our relation, and we can easily find out the COP value. So always remember, I always tell you to take care of the units. So here the temperature units are given as degree Celsius, but we need to convert them first to our SI unit. So minus 6 plus 273 divided by 25 plus 273 minus T1. T1 is nothing but minus 6 plus 273. Okay, so the value of this relation is nothing but 8.61. So the COP value we have already found out as 8.61. So COP value is nothing but 8.61 we have found out. But what is actually COP? What is actually COP of a refrigerator, or a COP in terms of refrigeration? That is desired output by desired input, desired output by desired input. But what is the desired output of a refrigerator? It is the amount of coolness produced, or amount of refrigeration produced, or the refrigeration effect itself. The refrigeration effect divided by what is the denominator? Desired input, or what is the input that we are giving in order to make our refrigerator work? It is the net work done, or the work done by the compressor. Okay, so here here in the question, what we need to find out? We need to find out the power required to drive the unit, assuming that the cycle operates on reverse Carnot cycle. So assuming that it is a reverse Carnot cycle, we have found out the COP value. But the COP value is nothing but refrigeration effect by net work done. So the net work done, or the power required to drive the unit, will be nothing but refrigeration effect divided by COP. Refrigeration effect divided by COP. It will be nothing but 700 divided by 8.61. 700, it was kilojoules per second. So the answer itself is given. It will be found out as kilojoules per second. The value is found out as 81.27 kilojoules per second. So that is the answer to our first question. The power required to drive the unit is nothing but 81.27 kilojoules per second. Now we are not stopping there. Now we are again continuing with our question. How much quantity of ice can be produced in one day from water at 25 degrees Celsius? We need to find out how much quantity of ice can be produced in one day from water at 25 degrees Celsius. So here it is given in the question. We are converting water at 25 degrees Celsius to ice. Okay, nothing else is mentioned in the question, so we can take the temperature of ice as 0 degrees Celsius itself. But please take care, Sometimes in some questions, the temperature of ice may be given as -1 degree Celsius or -2, -4 degree Celsius, like that. So in that case, we have to take that temperature. But here, nothing else is mentioned about the temperature of ice, so we can safely assume it as 0 degree Celsius. ഇതുകൊണ്ട് ഇവിടെ so what is given in the question? Suppose suppose we are keeping some water at 25 degrees Celsius. 25 degrees Celsius normally it is our room temperature. Suppose we are collecting some water in a reservoir or a pot or in some container. We are keeping water at 25 degrees Celsius and we are keeping this inside our domestic refrigerator given in the question. The question is, our domestic refrigerator will produce the refrigeration effect and slowly convert this water at 25 degrees Celsius to ice. So they are asking how much quantity of ice is produced or can be produced in one day by this domestic refrigerator if we are supplying water at 25 degrees Celsius. Okay, then for calculation purpose, they are giving the CP of water as 4.187 kilojoules per kilogram. So we need to find out this value. How much quantity of ice, അതായത് വാട്ടർ 25 ഡിഗ്രി സെൽഷ്യസിൽ സപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ എത്ര ക്വാണ്ടിറ്റി ഐസ് ഒരു ദിവസം കൊണ്ട് നമ്മുടെ ഡൊമസ്റ്റിക് റെഫ്രിജറേറ്റർ പ്രൊഡ്യൂസ് ചെയ്യും. Okay, so you slowly break down the given question or the given question sentences in your own sentence, then all such questions will become very easy to you. Okay, so here we are giving the water in liquid form as at 25 degrees Celsius. This domestic refrigerator will be absorbing heat from the water which is at 25 degrees Celsius. It will be slowly by slowly it will be taking away heat from this liquid water and slowly getting converted into ice. So what is happening over here? The liquid water which was at 25 degrees Celsius, it is slowly getting converted to its solid state, that is ice at 0 degrees Celsius. So now we before we find out the quantity of ice produced, now let us focus on this conversion of liquid water at 25 degrees Celsius to ice at 0 degrees Celsius. In order to transform this liquid water at 25 degrees Celsius, please please listen, please concentrate. That is, here we are taking liquid water at 25 degrees Celsius. We need to transform it to solid ice at 0 degrees Celsius. So here there is a phase transformation. Okay, and at the same time we have to remove the heat from water also. So what all are the steps involved in this conversion of liquid water to solid ice? Okay, so here initially the liquid water was initially at 25 degrees Celsius. The domestic refrigerator will be slowly removing heat from this liquid water at 25 degrees Celsius. First, it will transform it to water at 0 degrees Celsius. Okay, till the till the temperature of water becomes 0 degrees Celsius, it will remain as liquid itself. Okay, so from 25 degrees Celsius to what? From liquid water at 25 degrees Celsius to liquid water at 0 degrees Celsius, the amount of heat absorbed will be given as sensible heat. Okay, ഇത് നമ്മൾ ജൂനിയർ ക്ലാസ്സിൽ നമ്മൾ പഠിച്ചിട്ടുള്ളതാണ്. In junior classes we have studied sensible heat is nothing but the heat required to simply increase or decrease the temperature of a substance without any change in the phase. Okay, without any phase transformation, what is the heat transfer happening, which is causing only temperature change? That is the sensible heat. Sensible heat is mathematically given as mcp delta t. So mcp delta t is the heat required to be absorbed from liquid water at 25 degrees Celsius to transform it to again liquid water at 0 degree Celsius. So first it will be transformed from liquid water at 25 degree Celsius to liquid water at 0 degree Celsius. Okay, that much heat is given as MCP delta T, or sensible heat. Now our water is remaining as at 0 degree Celsius. We need to convert it into solid ice at 0 degree Celsius. There or now only the phase transformation is happening. Whenever a phase transformation is happening, what is the heat transfer involved? Heat transfer involved will be represented as latent heat. The latent heat mathematically can be represented as ml, or mass of the substance involved times the latent heat. Okay, so so here in our question, liquid water from 25 degrees Celsius is first of all converted to liquid water at 0 degrees Celsius. So the first heat transfer involved will be sensible heat, that is mCp delta T, where m is the mass of the water, Cp is the Cp of water, delta T is the change in temperature happening to the water, that is from 25 degrees Celsius to 0 degrees Celsius. Okay, so then the next transformation is the liquid water at 0 degree Celsius is transformed to solid ice at 0 degree Celsius. Then the phase transformation is happening. That heat transfer involved is the latent heat, mass times latent heat. So here we do not know the value of m, or mass of water or mass of ice getting produced. Nothing is mentioned in the question about that. Here they are simply asked us to find out that quantity of ice. They have not mentioned how much quantity of water they are supplying also. So for safety purpose, or for calculation purpose, we are assuming that value as 1. We are taking the amount of water supplied as 1 kilogram. Okay, so ഇത് നമ്മൾ കാൽക്കുലേഷൻ എളുപ്പമാക്കാൻ വേണ്ടി തൽക്കാലത്തേക്ക് നമ്മൾ എടുക്കുന്ന മാത്രം. So the heat, the total heat absorbed from water at 25 degrees Celsius to convert to ice at 0 degrees Celsius, that is we are representing it as QA. QA will be equal to mCp delta T plus ml. By substituting all the values, m we are taking it as 1. Cp value it is given as 4.187 kilojoules per kilogram Kelvin. So it is kilojoules. So we have to multiply it by 1000 in order to convert to joules. Okay, then delta T is nothing but the temperature change happening to the liquid water. It was initially at 25 degrees Celsius. It was initially at 25 degrees Celsius. We need to transform it to liquid water at 0 degrees Celsius. So delta T is nothing but 25 minus 0. So this is mCp delta T. Then what is remaining? ml, mass times latent heat. Mass we are assuming it as 1. Then latent heat of water, it will be better that you remember it. So in many of the questions, this value may not be given in university exams also. So universally, the latent heat of water is assumed as 335 kilojoules per kilogram. So here also 335 times kilojoules. Kilojoules. So 1 kilo is 1000. So we are multiplying it by 1000, 10 raised to 3. So the final answer, the final QA is given as 439.675 kilojoules per kilogram. Okay, it is very easy to calculate this value, but we have to appreciate, we have to understand what is the meaning of this result. What is the result obtained here? The heat QA is equal to 439.675 kilojoules per kilogram. What is the physical meaning of this result? This will be the heat required to produce 1 kilogram of ice at 0 degree Celsius from 1 kilogram of water at 25 degree Celsius. അതായത് 0 ഡിഗ്രി സെൽഷ്യസിലുള്ള 1 കിലോഗ്രാം ഐസ് പ്രൊഡ്യൂസ് ചെയ്യാൻ 1 കിലോഗ്രാം ഓഫ് നമ്മുടെ 25 ഡിഗ്രി സെൽഷ്യസിലുള്ള 1 കിലോഗ്രാം വാട്ടറിൽ നിന്ന് എത്ര kilojoules of heat absorb ചെയ്യേണ്ടി വന്നു. So that kilojoules is 439.675 kilojoules. Okay, so what is the physical meaning of this result? That is, in order to produce 1 kilogram of ice at 0 degree Celsius, we needed to absorb 439.675 kilojoules of heat from water, which was initially at 25 degrees Celsius. So now let us continue with this. So here, now our question is, how much quantity of ice is produced in one day from this water at 25 degrees Celsius? So now we are going to find out that. So before that, in our question we need to find out the quantity of ice produced in one day. But before that, let us try to produce. Now let us try to understand what is the quantity of ice produced in 1 second by this domestic refrigerator. So we have already found out initially the refrigeration effect produced by this refrigerator, that is 700 kilojoules per second. Or please note this unit. Always take care of the units. So the refrigeration effect is given as kilojoules per second. That is, what is the amount of heat absorbed by the refrigerator per second? That is 700 kilojoules per second. So our refrigeration effect was in kilojoules per second. Okay, then in just before 1 second before, we calculated the QA, or the heat absorbed. Okay, heat absorbed from 1 kilogram of water. That is nothing. That unit was in kilojoules per kilogram. Kilojoules per kilogram. So QA was in kilojoules per kilogram. A little consideration will help us to find out the quantity of ice produced in 1 second. How we can find out? We just need to divide this kilojoules per second by kilojoules per kilogram. So this kilogram will go above in the numerator, kilogram per, the second will come down in denominator. So the final result will be in kilogram per second. So that is nothing but our required value. So how we can find out this quantity of ice produced in 1 second? That is refrigeration effect by QA. Refrigeration effect by QA. So that is 700 divided by 439.675, and that value is nothing but 1.59 kilogram per second. What is the physical meaning of this result? 1.5 kilogram per second. It means in 1 second, our domestic refrigerator will produce 1.59 kilogram of ice. It means in 1 second or per second, our domestic refrigerator will produce 1.5 kilogram of ice. Okay, but we do not require that value. In our question, we need to find out the quantity of ice produced in one day. Means we have to convert this per second into per day. Okay, so we need to multiply that we already know how to convert this per second into per day. That is, we have to multiply this value with 24 into 60 into 60. So that will be around 137,556.14 kilogram per day, or it is something around uh, 1,37,556.14 kilogram of ice per day. So this much quantity, that is around lakhs of kilogram of ice, can be produced in one day by a simple uh, domestic refrigerator with a capacity of 200 TR and operating between -6 degrees Celsius and 25 degrees Celsius. So, so now we know the capability of our capacity of our refrigerator. So now this is the answer. Thank you, all of you.